Today we're going to be looking at specific heat capacity, and it's the idea that we can calculate the amount of heat lost or gained depending on which way the heat is moving. And we're going to do that using the specific heat capacity. As a reminder, we looked at heat, and we know that heat is the energy that is in the process of flowing from a warm spot to a cold spot. It's the movement of energy due to temperature. And we looked at these two buckets. Now the thing with these two buckets that made it easy is they're both water, and they're both the same mass of that water, and so we're looking at the same substance and same amount, which made it really easy to do our calculations. However, today we're looking at different substances and different amounts, so we need something new. Specific heat is our answer. Before we get too far, let's talk about heat and the units that we can use. So heat is the transfer of energy due to temperature change, and normally you'll see it in calories. Calories, the amount of energy or heat needed to raise the temperature of 1 gram of water 1 degree Celsius, just by definition. You've seen calories before, like on your cereal boxes, but notice how those calories are written. Be very careful when you take your notes right now. Calories with a big C are different than calories with that little c. Look at the whole milk. You can see that there's a big C. Those are food calories. 1 big calorie is a food calorie. What I have defined for you here at the very top is a little calorie. 1 little calorie is the amount of energy you need to raise 1 gram, 1 degree. You have 1,000 little calories in 1 big calorie. So these are the conversions that we'll need to know. 1,000 little calories is equal to 1 kilocalorie, which is 1 big calorie, which is a food calorie. So what happens inside your body actually is you take in food, and the food will break apart and be an exothermic reaction, and your body will use the heat, calories is heat, to do many different things inside of your body. That's why we use calorie in the lab as well as on our food. Now in the lab, that's not the SI unit. The SI unit for heat is actually joule. Not like the jewels you wear, but joule spelt a little differently. That's the SI, the International System of Science system for units of heat. And the conversion between there is 1 little calorie, careful when you write it, is 4.184 joules. I love this Coca-Cola can, low joule cola instead of a Diet Coke. I don't know where they found it, but I want one. Okay, so let's bring this heat idea into endo and exo. We know that heat has the letter Q. So now that we know what heat is, and we're going to be able to calculate it today, we've got units for it. Notice we've got Q representing heat. Why they picked Q, I don't know, but that's what they've got. When heat is leaving, it's exothermic, and that's a negative process. Negative because it's leaving the system. Endothermic is when Q is positive, because heat is coming into the system. It's going in, so it's positive. Alright, so we know what Q is. We can do units for Q, which is heat, but now let's be able to calculate using a new equation with Q. Because before we were looking at 2 buckets of water, same mass, but now we're looking at 2 different substances, like this pot of water. You've got the pot, which is a metal, and the water, which is the liquid, and we've got different masses of the 2. So how do we calculate how much heat is being exchanged? We're going to need specific heat for that. Specific heat, check out those fancy units. Specific heat looks at joules, that's the top unit, divided by grams times degrees Celsius. It's kind of like density. Density has 2 parts, grams per milliliter. Well, joules has 2. Specific heat has 2 parts also, joules per gram degree Celsius. It's the energy required to raise the temperature of 1 gram of any substance 1 degree Celsius. I'm sure you've written it down by now, and you realize that you've written something down very close to it. Take a look at your definition of calorie, and now look at specific heat. You can see the only difference is that word any is replaced with water in calorie. Calorie is defined based on water. Specific heat we define based on any substance. So you can have water has a specific heat from the cement, from the grass, from any substance that we have. So specific heat isn't specific to water. Specific heat allows us to do this lovely equation. Let's take a look at the variables. We've already learned that Q is heat. We're going to be using it in units of joules. When you use this equation, make sure you're in joules for heat. M is our mass. Mass is in grams. When you use this equation, make sure it's in grams. C is the letter we use for specific heat. I see it sometimes as S also, but your textbook tends to use C, so I'll go with it. C for specific heat. And we just learned the units for that one are joules per gram degrees Celsius. And finally, that triangle we've learned is change. That's the change in temperature. And whenever we do change, we always look at final minus initial. Our change in temperature will need to be in Celsius, since our specific heat is in Celsius. That way all of our units cancel. Okay, what I'm looking for you to do is use that equation you just saw to solve this problem. It's basically put in some numbers and come out with an answer, and I'd like to see your answers in the Google form. We'll see how well we do, and if we have to cover it, we will tomorrow. Bring your questions, and I'll see you then.